So ROM, types of ROM, so PLAs and so types of PLDs here. So we'll see what is this memory and what is this memory exactly means actually. Okay. So what is memory?
which
So what is the
stores
first
some
thing?
information.
Memory?
It stores some information.
Huh?
Which stores some information, sir.
Which stores some information. So when we talk about digital circuits, what will it store?
Data.
So which data?
Binary data.
Resulting data.
Binary data. So the memory is used to store the binary data. So we'll talk about your mobile phones or laptops. Okay. So what are the kinds of memory available?
RAM and ROM, sir.
RAM and ROM. So what is RAM and what is ROM? So we'll take your mobile. So what is the purpose
Yeah,
of
sir.
RAM and what is the purpose of ROM? So all are using smartphones, right? So
Yeah, sir.
what is RAM and what is ROM?
ROM is nothing but having storage, sir.
Okay.
RAM is internal memory, sir.
Increase the speed of internet or connection, sir.
Huh?
Random access memory, sir.
Random, yeah, I know the definition, man. So I want to know the difference. You're all using smartphones and you people are EC people, right?
Increase the speed of using network, sir.
Yeah, using network speed. Okay. So how will it increase the speed of the network? How can you say that it will increase the speed of the network?
Through our signal passing.
No, it is nowhere related to the signal. So more
Processor.
of RAM, you're saying that your mobile is like will be used for. I mean, your mobile will be fast. Your operating speeds of the mobile will be fast. So that is what you are
It's
saying, right? So how can you
it's based
justify?
on
How can you
processor, sir.
justify? Huh?
Processor.
Huh? Processor. So processor,
Yes, sir.
fine. Your processor is reason for the faster access, but the RAM is also one of the reasons. So nowadays we are getting the RAM with a higher like so minimum 4 GB of RAM we are using, right? So
Yes,
what is
sir.
the purpose of using this 4 GB of RAM? What is the purpose of using your 4 GB of RAM?
To increase the performance, sir.
To increase the performance. Yeah, but tell me that. Don't tell me the general answers. Right. I need a specific proof for this. So I don't need a general answer.
To reduce the
To reduce the.
time for any downloading purpose, sir.
Mm, no. So for that, your internet speed is fine. So what are the major memories available in your mobile? Same memories in your mobile. No?
RAM and ROM, sir.
RAM and ROM. So what is this? For example, I have a RAM of my mobile is OnePlus 60, and I have a RAM of 6 GB, right? So this is the RAM, and I have ROM. ROM is of 128 GB. So ROM in the sense read-only memory, so which is of 128 GB here. So what is the purpose of this 128 GB, and what is the purpose of this 6 GB?
To store the down files and something apps in 128 internal GB, sir.
Okay. The other one RAM.
Usage of the apps.
Usage of apps. Fine. So generally, so RAM is a volatile memory as the power is on. Okay.
ROM is worse. Non-volatile.
Yeah, sorry. Excuse me. So power gone. So fine. So what we are discussing here? So we are discussing about RAM and ROM here. So if I take your mobile, so am I audible?
Yes, sir.
Yes, sir.
Yes,
So
yes,
if
yes.
you take your mobile, so we have RAM and ROM. So generally, your mobile will be like this. So you'll be having a RAM and you will be having a ROM here. So ROM in the sense, so all the operating systems. So what are the operating systems we'll be using? Like some mobile operating systems. So we'll be using. So we are using Android operating systems, right, in your mobiles generally. So
Yeah,
Android
sir.
and 10. So what is the version now? It's Android 10, right?
Yes,
Android 10
sir.
or 11?
10, sir, or some.
Yeah,
Well, sir.
12. Sorry. I mean, I'm not updated with this Android. I mean, so we are using different versions, right? So we started with 3, 4, 5, 6, 7, 8, 9, 10. So every version is given different name, and we have iOS 10, iOS 11. Okay, so each version is having we are having different versions of the Android here. Okay, so that operating system, that is a program, right? So any operating system is a program. The program should not be erased here. Okay, so that program should not be erased. So that program will be installed into your ROM. So which is a read-only memory. We can only read from that. We can't erase that, or we can't write into that. So what is the meaning of writing? So take your textbook. So textbook. So if I want to read anything from the textbook, so what I'll do? So what I'll do, I'll extract the data from the textbook. So just I'll read it and I'll again use it. Just what I'll do, I'll take the information from the textbook only. Okay, but I can't write it into your textbook because it is already written into the textbook here. So it is a read-only memory. Getting my point here? So
Yes,
we
sir.
can only read in case of the read-only memory. So read-only memory in the sense it has already whatever the apps you are having. So whatever the operating systems you are having. So whatever the default apps you are having. So that will be stored into the read-only memory. Okay. So that is stored into the read-only memory. So coming to the random access memory. So whenever I open the app, whenever I open different kinds of apps, so what happens here is so the data which is related to that present app which we are using, okay, the data which is related to the present app which we are using will be stored in the RAM, okay, which will be stored in the RAM. So we'll take the data from this mobile. We'll take the data from the we'll take the data from the ROM here, and that ROM data will be transferred into RAM. Okay, so if you are having multiple apps, right? So multiple apps will not use all the apps at the same time. Okay, so which are the apps which are currently being used are stored in the RAM, are stored in the RAM. So the apps which are currently used so are transferred into the RAM. Okay, and we'll use that apps with that help of RAM here. So here, read-only memory is not used here in case of the present usage here. I mean, while using any kind of apps here, so that app should be transferred to the data of app should be transferred into the RAM here. So if I open multiple number of apps, so what happens there here is so data will be like so if I have more amount of RAM, I can open more amount of apps here. Okay, so why the phone hangs in the sense most of your phone hangs in the sense. So if I open more amount of apps here, so the data which is related to this apps will be stored into the RAM here. So if the RAM becomes full, then they automatically they'll be hang out of the phone, or I mean the systems the mobiles become slow here because of opening of the multiple number of apps. So that's why we prefer more amount of RAM so that we can open more number of apps and the system will become more faster here. The mobile will become more faster. Okay, so RAM stores only the apps which are executed currently, so which we opened right now. Okay, so when we restart the system mobile here, so all the apps will be closed, all the apps data will be closed. I mean the RAM is volatile here, so the RAM is volatile here, so the data which is there, so which will be restored to the earlier version, which will restore to the normal position here. Okay, so general game చేస్తుంటాము. So we open WhatsApp, we have opened YouTube అన్ని ఓపెన్ చేసింటాము, సో parallel గా ఓపెన్ చేసింటాము. Okay, so if I restart them, so all of them will be in the normal restart initial state. So we have to again open and we have to again make the choices. So or else we can close that and we can open. So when it is last used here. Okay, so if I opened a video, okay, and I'll go to switch to another app. So what happens? So from another app to YouTube, if I come to the YouTube again, so it will be in the same position only. Okay, so we will go for the last searched item only. So whereas in case if I restart the mobile here, so what happens here is, so it will erase all the data which is presently used, that is the data in the RAM here. So it will again start with the initial state here. It will again start with the initial state. Yes or no?
Yes, sir.
Okay, so RAMs
Yeah,
are
sir.
used here. So they are used to store the data. They are used to store the data of the apps. Okay, so which are presently being used, so where will we get this data? So the data will be transferred from ROM to the RAM. So when we are using this app, data will be transferred from RAM to the ROM. Getting my point here?
Yes, sir.
Okay, so first of all the operating systems, so I mean the software which is required to run your mobile, so which is your Windows in case of your laptop or systems, okay, or Androiding operating systems in case of your mobiles, or iOS in case of your iPhones. So they'll be having the pre-installed OS into the ROM here. So ROM is nothing but, so we can't erase that. So it is a read-only memory. We can't erase it. Okay. So we can only read the data from that RAM here. So ROM. Okay. So afterwards, so what is the purpose of RAM here? So RAM, what it will do here is it will take the data, so which is presently being used, so which is currently being used by the user. Okay, so from the read-only memory to the RAM here, so there we can modify that. We can modify the tab, or we can write the data, or we can do any kind of operations. So when we open this RAM here, okay, so RAMs are meant for storing the data, which are data of the apps or data uh, of the programs which we are currently being used here. ఓకే, సో ఏవైతే ప్రెజెంట్ యూజ్ చేస్తుంటామో, ప్రెజెంట్ మనం ఏదైతే యూజర్ యూజ్ చేస్తుంటాడో, ప్రోగ్రామర్ యూజ్ చేస్తుంటాడో, ఆ డేటా రిలేషన్ అంతా కూడా, డేటా రిలేటెడ్ ఇన్ఫర్మేషన్ అంతా కూడా ర్యామ్ లో ఉంటుంది. Okay, so RAM memory is volatile here as long as the power is there. So as long as we'll keep the mobile on, so the RAM data will be available. So or else it will be erased. Okay, so when you restart the system, so what happens when you restart the system? It will start from the initial boot screen to the Windows, like, so it will open the things here. So no app will be opened there. Okay, so no document will be opened. So when we restart the system, okay, so when we restart your mobile also the same thing. So it will have the same screen, so that is available. Okay, so clear? So there's a general kind of memory here. So memory is used to store the binary information. Okay, so where the information is retrieved when needed for processing. So we'll store the apps, we'll store the information related to the operating systems into the ROM here. So from ROM, we'll retrieve the data when it is needed. Okay, so if I want to open any kind of app, so data from this read-only memory is transferred to RAM here. Okay, so when data processing takes place, the information is transferred to selected registers in the processing units, and will finally obtain the results, and results are again transferred to the memory back here. So generally, apart from mobiles, so what we'll be having here is, so we'll be having the memory, we'll be having the input devices, we'll be having the output devices here. Okay, and we'll be having some registers kind of thing we'll discuss later. Okay, so what happens here is I'll be having a memory. Okay, so wait a minute. Fine. So this is the memory. This is the input device, and this is the output device. What will feel, and here is a processor. So this is processor. So memory, output, input. Okay. So I'll give some input. I'll write some program that will be stored in the memory. What are the programs? It will be stored in the memory. Okay. When the processor requires that program, it will ask the memory. It will ask the memory. It will take the data from the memory to the processor. It will process the data. Okay. And results will be given as output here. So results from the processor will be given as output. So we will be again stored in the memory. So this is not here. The data will be processed here. Again, it is stored in the memory, and from memory, the result is given as output here. So this is a normal scenario that will happen in any kind of processors here. Okay. So first of all, inputs. So if I write any kind of program, so if I write any program, so I'll give the input of program like a plus b. Okay. So a plus b. So I'll write this program. So add. I'll write a program. So I write an instruction like. So add two numbers like a and b. So there is a program. I'll give this input. This is stored in the. This is stored in the memory. Okay. And the processor, what the process will do? It will take this instruction. So instructions and data are stored in the memory. It will process this instruction, okay, and it will get some result. So it will get the result of a plus b, and it will again store into the memory. And I need the result of a plus b, where I can find it from the memory here, and from a memory it is given to the output unit here. Getting my point here?
Yes, sir.
Okay. So
Yes,
memory
sir.
will be used for storing the instructions. They are used for storing the information, right? So information is fine. So in the next level, so what we have to understand is it is used for storing the instructions. It is used for storing the data. Okay. It is used for storing the instructions and data. So for example, if I say that, we need some values for A and B, right? So A and B values are stored in the memory. So what I can say here is A and B values are initialized and they are stored in the memory under. Okay. So adding two numbers. So the inputs, so what are the data will be stored in the memory, and also the same time the instructions will be stored in the memory. Okay. So all the kinds of data and instructions, or we can say that all the kinds of programs and data will be stored in the memories here. Okay. So data will be stored in the memories, and this information or these instructions will be retrieved by the processor here. So whenever it needs here. So if I want to process that instructions, if I want to process the data, the processor will take the data and it will process the data. So processing is different steps. So we'll know that later. Okay. And after processing the things here, so the result will be again stored in the memory, and if I want the result, so again I have to access the memory here. Again I access the memory. Clear? Okay. So what are the information? It is received here, and whatever the information input will be stored in the memory, and whatever the information I need to require, I need to take it from, I need to give it to the output device, will be taken from the memory. Getting clear? So clear about this.
Yes, sir.
General topics, but we might not understand in this way. Okay, we will be using mobiles and we will be using laptops, but we don't understand those functionings. Okay, and so generally these memories are of two kinds. I already told you: random access memory and the read-only memory. Okay, so random access memory and the read-only memory. Okay, and so we will be having two operations in case of random access memory, that is read and that is write. Okay, we can perform both read operations and the write operations. Okay, and in ROM we can perform only the read operation. Okay, we can perform only the read operation. Okay, so this ROM is called as a programmable logic device. Okay, it is called as a programmable logic device. So there are many programmable logic devices available. So we'll discuss about the programmable logic devices in the later classes. So the meaning of programming is like the binary information that is stored in a device will be in a specific fashion here. Okay, And the programming refers to the hardware procedure which specifies the bits that are inserted into the hardware configuration of the device. So, wherever, whatever we have the bits here, so we'll follow some patterns here. Okay, so the pattern in which we are storing is called as a programming in case of the ROM here. Okay, so the pattern what we are using. Okay, so how the bits are inserted into the memories here, so that is called as a programming here. Okay, so how the bits are inserted, how in what fashion they are inserted, so in what logic they are inserted, so that is nothing but the programming here. That is called as a programming part here. Okay, and so there is a brief intro here. There is a brief intro of this RAM and ROMs here. Okay, so we'll see a detailed version of RAM and ROM also. Okay, we study more about RAM and ROMs today. Okay, and so wait. So coming to the random access memory, this is how it will be. Okay, visible, right? Yeah, so there is a
Yes,
block
sir.
that a memory unit. So in specific, it is a random access memory unit here. Okay, so it is how it will be. Right. So we'll be having two operations. These are the control signals. These signals are called as the control signals. Read operation and the write operation. Okay, it is a control signal here. Okay, and coming to this next operation, we'll be having address line. So each memory, okay, so each memory will be having some address lines. Okay, so if I say that 0, 1, 2, 3, so each memory will be having some address lines. So how to access the memory? So if I say that I'll be writing the input and that input will be stored into the memory. So where it will be stored? So it will be stored into a specific location. So how to know that location? With the help of some address. Clear? So when I write anything into the memory, or if I want to read anything from the memory, so I need to know the address of that memory. Okay, I need to know the address of that memory location because each memory location is addressed here. Okay, each memory location is addressed. So how many address lines will be having here is k address lines. So if I say that it is a k address lines, so the number of locations in the memory will be equal to 2 power k. Okay, so if I say that the address is lines is of 8-bit, so k is equal to 8. Okay, so how many number of locations will be there in the memory and so 2 power 8. Okay, so there will be 2 power 8 locations here. Okay, so 2 power 8 locations, and each location, okay, so each location will be of size, so which is equal to the inputs here. So n data input lines and data output lines. So what we can say here is 2 power k words. Okay, so this memory unit will be having 2 power k words. So the word size will be of equal to n here. The word size will be equal to n. So what I can say here is 2 power k into n words here. 2 power k into n words. So what is k here? So k is nothing but the number of size of that size of the address lines here. Okay, so it is the size of the address line. A specific a single address line will be of size k here. Okay, and n is the size of input lines. I mean number of how many number of inputs. So that will be the number of size of the word, each word here. Okay, wait. So this is the memory here which is having read operation and write operation. We'll be having k address lines here. Okay, so k bit address line. So this number of locations in the memory will be equal to the 2 power k. Okay, so 2 power k words will be there, and here word is equal to, generally what is the size of word is nothing but the number of data input lines here. So many number of data input lines, so that will be the size of each word here. Okay, so each word size is of n bits per word here. Okay, so 2 power k into n words here. Okay, so we'll be having 2 power k locations, and each location is of 8 bit here. So for example, if I take it as 8 here, so k is equal to 8, and n is equal to 8 here. Okay, so 64, so 2 power k is like 2 power 8. So what is 2 power 8?
256.
256. So 256 locations will be there. Each location will be of size of 8 bit. Each location is of size of 8 bits. So each locations 256 locations ఉంటాయి. Each location size ఎంత ఉంటుందంటే 8 bits ఉంటుంది. And address bit size ఎంత అంటే 8 bits ఇక్కడ. Okay, so we'll see that. And if I perform read operation, we'll take the data from that location here. If I perform write operation, I'll write the data into the memory here with the help of these two signals here. With the help of this two signals. Okay, so you can see here. Suppose if you are having so 1k into 16 memory. Okay, so what is the meaning of 1k? So here I'll explain the 1k. So 1k is equal to 1024. So that is equal to 2 power 10. So that is 1k. Okay, so 1k is equal to 1024. Okay, so that is equal to 2 power 10. Okay, and so 2048 is 2k. So into 2, it is 2k here. Okay, and 1m is equal to 2 power 20. So 1 stands for mega, it is equal to 2 power 20. And giga is equal to 2 power 30. Giga is equal to 2 power 30. If I say that 64 here, so 64 is equal to 2 power 6, 2 power 6. So k is equal to 2 power 10. So it is equal to 2 power 16. 64 k is equal to 2 power 16 here. So 2m is equal to m is equal to 20 here. So 2 power 1. So 2 power 21 is equal to 2m here. So giga is equal to 2 power 30. So 4 is equal to 2 square. It should be equal to 2 power 32. Okay, in case of this binary, so 2 power 10 is equal to 1024. So that is called as 1k. Okay, if I take this, the memory size is of 1k into 16 annar. The meaning of this is, so 1k into 16. So 1k is nothing but, so 2 power 10. So 2 power 10. So the 10 is the size of the address here. So address will be of size 10 bits here. And each 2 power 10 locations will be of the size 16 bits here. 16 bits in each word here. So what I can say here is, so 1k into 16 memory means, so we'll be having 2 power 10 into 16 words. So the size of the memory is 2 power 10 into 16 words. So we'll be having 2 power 10 memory locations, and each memory location will have 16 bit of data here. Each memory location will be having 16 bit of data. Okay, so you can see here. So address size of k here, so k is equal to 10. So 10 and 10, so we'll be having, it will start from 0 0 0 0. So 1023. So that is 1024 locations, right? So 0 0 to 0 to 2 power k minus 1. So numbering will be like equal to 0 to 2 power k minus 1 here. So that is 0 to 1023. Okay, so this is the binary values of this one here. Okay, so 1023 binary values will be like, so 2 power 10. Okay, so 0 to, we'll be having like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. Okay, the same way we'll get up to 2 power 10. Okay, so 2 power 9, sorry. So what is this value here? So 1 into, so what is 2 power 9? So what is 2 power 9?
5 to 1.
1
Yeah, 512 plus 2 power 8,
256.
256.
256, plus 2 power 7, 128.
128.
128.
Yeah, plus 2 power
64.
64
64.
plus 32.
32.
32.
Okay, and next one is 16,
16.
8, 4,
8,
2.
4,
So when
2.
all of
4,
them are
2.
equal to 1, so when all the 10 bits are equal to 1, it is equal to 1023. So this is the binary value. Okay, so the binary value is from 0 to 10 ones here. So that is 0 to 1023. So this is the number of memory location we'll be having here. This is the number of memory locations. So each memory location will be having 16 bit of data here. So 4, this is 4, this is 4, and this is 4, 16 bits. Okay, so 1024 locations. So each location will be having 16 bit of data here. So we can say that 1024 into 16 memory here. What size of memory is 1024 into 16. The contents of 1024 into 16 here. Okay, so here what is it has to be observed here is what it has to be observed here is the memory unit. So the memory unit has how many number of locations here? It depends upon the number of address lines. Depends upon the size of address lines. If we are having 2 power k address lines here, k is the size of address lines. So we'll be having 2 power k, 2 power k number of locations. And what is the size of each memory is? It depends upon the word here. So it depends. So we can specify that. So whatever the inputs we are having, so those inputs will be taken as the size of the words here. So normal commercially available memories, each location lo 8 bits మాత్రమే store చేసుకోగలం. So remember this point. So whatever the commercially available memories here, so most of the memories, so each memory location can store 8 bits. So 8 bit of data only. So 1011, so 1001. So only 8 bits are stored in each memory location here. So generally, so in general. So in problems, we can specify any kind of locations here. Okay, and there are two kinds of operations here. Okay, so we'll be having read and write operations. Okay, so if I want to perform read operation, so this should be equal to 0. If I want to perform write operation, so this should be equal to 1. Sorry, if I want to perform read operation, so read should be equal to 1. If I want to perform write operation, so write should be equal to 0. Okay, so you're having a signal here. So what we'll do here is, if I want to perform read operation, so 1 is written on read signal here and data is extracted here. Okay, if I want to perform write operation, 0 is written on this line and data will be written into this one here. Okay, these are the two control signals which will perform the read and write operations on the random access memory. Clear?
Okay.
Okay.
Yeah, sir.
Yeah, this is a brief intro of this. And RAM will be having two kinds of RAM here: static RAM and dynamic RAM. So it depends. I mean, static RAM and dynamic RAM are differentiated with the help of the architectures. I mean, the storage, how we store the data. So we'll see this RAM here. So there's a basic intro of this memory here. Wait. We'll be having two kinds of RAM: static RAM and dynamic RAM. right? So static RAM and dynamic RAM. So we are having static RAM here. You check here. The static RAM consists of internal latcher and store the binary information. So in the static RAM, so what it will do, as long as the power is applied to the unit here, so the data will be remain. So otherwise, data will be lost here. So dynamic RAM will be having capacitors here. Okay. So static RAM uses latches. We'll discuss about the latches in the next classes. So which are nothing but the storage devices here. So we'll be having some latches is nothing but latch is a storage device. So these storage devices will store the data as long as the power is available. Okay, and coming to the dynamic RAM, so this also it will store the data, but it will store the data with help of capacitors here. Okay, so the charging and discharging of the capacitors are used to store the data or retain the data. Okay, will retain the data to the previous value. Okay, so we'll be having the capacitors here. The capacitors charging will store the information and discharging will retain the previous information. Okay, the stored charge on the capacitors tend to discharge with time here, so that they'll be available for a specific amount of time. Okay, so and the capacitors must be periodically refreshed by the dynamic memory. Okay, so it will periodically refresh. So the capacitor chargings and dischargings are used to store the data, or it is used to retain the previous values. Okay, so refreshing is done here. So for every few milliseconds, the refreshing is done. Okay, so and so coming to this DRAM here, it consumes less power. So compared to the static RAM here. Okay, compared to the static RAM. So static RAM uses latches to store the information, and dynamic RAM uses the capacitors. Okay, and dynamic RAM uses the capacitors. So capacitors charging and discharging will provide the storage of information or uh, retaining the previous value of the information. Okay, so there is a difference between static and dynamic RAM here. Okay, so next class what we'll see here is, so we'll see about the ROMs here. So we'll see the decoding part of the address here. So we'll see that, and we'll see how the memory decoding will be done. Okay, so decoding the sense, so I'll let you know what is the meaning of decoding in the next class. Okay, so which is done with the help of decoders generally. Okay, so this is a little bit of theory. So for one or two topics, so we'll be having, so that theory is just for your information. So next PLDs, what are the PLDs topic? So they will be having the problems. Okay, so and we'll solve those problems. Clear? So what you have to do here is study about this memories. So just on a brief note. So just okay, Chadavan. So you'll understand
Okay, sir.
the meaning of memories and all. Okay, and be prepared with this combination circuits. I'm a little bit busy, but I want to complete my syllabus also. So what we'll do, we'll definitely have some sessions, so which are questionnaires. Like, so we'll have the question and answer sessions. Okay, any kinds of doubts, any kinds of information so you can share and we can clarify those doubts in some other sessions. Okay, I'm not finding time, so busy with other commitments in the college also. Okay, so we'll see. Meanwhile,
When college opens, sir?
Emma?
College when opens?
College, don't know actually. The date is like they said 8, but the whitewash has to happen. The most of the COVID patients stayed here, right? So whitewash జరిగి శానిటైజేషన్ జరుగుతుంది. So sanitization జరుగు అది ప్రాసెస్ కొంచెం గవర్నమెంట్ ఇన్స్టిట్యూట్స్ కాబట్టి it will take some time. Okay. Uh, Hope it will be all good if it opens on second week. Okay. So we thought that
Okay,
this
sir.
first week. So if everything is good, it opens on second week. I know staying in home for quite long time is quite difficult for you. Uh, don't know. So what is the next scenarios, and even we are bored to take online classes. Okay. So let's see. But meanwhile, you study this concepts of memories. So within 4-5 days or within this week, we'll finish off this fourth unit. So fourth unit is very simple. The concepts of PLAs and all, these are very simple. So we'll see these concepts later. So within this week, we'll finish this. So just if you know the K maps, everything is easy. Okay. Right. So drop your attendance and see you tomorrow.
Okay, sir.
Yeah.